This video is going to go over pages 31 through 33 of the workbook. This is going to talk about polygons, in particular quadrilaterals. There are several quadrilaterals that are very important to learn about. The one that you won't be responsible in the SOL for is kites, but you need to know about parallelograms, rectangles, rhombuses, squares, and trapezoids. These three up top, they're all special types of parallelogram. A square is also a rhombus and a rectangle. So a square has all these properties. Rectangles just have the properties of parallelograms. And rectangles and rhombuses just have properties of parallelograms and rhombuses. The things that you really want to take away, though, because that's a lot to remember. First off, we have rectangles. You should know there are 4 congruent and right angles. So if I draw a rectangle, let's go a little bit longer. I'll skip that right now. We'll come back to that in a second. If I draw a rectangle, I know that there are 4 right angles. That's what its definition is. The other thing that you need to know about it is the diagonals are congruent. This is a property that's special to rectangles. It's not a property that's true with rhombuses or parallelograms, but both of those diagonals will be congruent. The thing that you need to know about a rhombus is 4 congruent sides. Hopefully everybody knows that. So a lot of times we'll see a rhombus drawn like this, and people will say it's a sideways square. It's really not the best explanation for it, but all the sides will be equal. It won't necessarily have right angles. And its diagonals will be perpendicular, so 90 degrees. So whenever I have the diagonals and I have blue, I know that all 4 of these are going to be right angles. So remember, that means 90 degrees for each angle that's formed by the diagonal. Let's go back to our first page, though, and look at some examples and how you would prove some of these properties. So we need to name we need to have the best name for a parallelogram. We have -6, 9. So right there is going to be A. We also have 5, 10. That's going to be B. 6, -1, C. And 5, -5, -2 is D. A little bit off. So right away we can tell this is not a trapezoid because we know it's a parallelogram. A trapezoid is not a parallelogram. So we know the answer is not D. So is a rectangle are 4 right angles formed. Remember, we can figure out that these are right angles from the slope formulas. So the slope of AD, remember, it's going to be rise over run. If you just count 1, so use 5 to show count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1. So that's going to be a negative slope. Rise over run. I also have BC, AB, and DC. I need to know that all of these slopes, what all these slopes are. So BC is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 over 1. So again, I have -11 over 1. So the slope of AB better be the negative reciprocal if it's going to be a right angle. Well, I go up 1, and I go to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the slope is 1 over 11. If I do the same thing with DC, it's going to be 1 over 11. So that means 4 right angles. Remember, whenever the slopes are negative reciprocals, that means that they're perpendicular to that right angle. We also need to verify that the sides are all equal. Well, since we already have this, 1 over 11, you should see that the side lengths are going to be the square root of 1 squared plus 11 squared. So remember, this distance here is 1. This distance here is 11. So we can use the Pythagorean theorem, and you'll see that all the side lengths are equal. That means it's a rhombus. And since we have 4 right angles, that meant it was a rectangle. And whenever a shape is both a rectangle and a rhombus, that means it's a square. So this is kind of a very long explanation to say C. A lot of you will probably plot this and say, yeah, that looks like a square. And better that you start that way to figure that out. Just get nothing at all. Let's go on to the next page. Again, we have things that we're plotting. So let's plot these points. So the first point is 0, negative 2. Let's get A. And we have negative 4, positive 6. 5, 6. Top 6. Then we have 9, negative 2. So just based off of this picture, I can eliminate some things. I know the answer is not a square or a rectangle. There are no right angles there. This is something with a graph. You have to figure that out. So are the sides parallel? Let's start there. Let's find the slopes of AB, CD, BC, and AD. Well, I know BC and AD, that's probably the easiest thing. I know I've talked about this a lot in class. We have fluid lines. So whenever we have a horizontal line, the slope is going to be 0. So the slopes for BC and AD are both 0. And the slopes of these sides here, AB and CD, again, it's going to be rise over rise. So 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. So AB is going to be negative 8 over 4. That's a negative slope. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Again, we have negative 8 over 4. This means it's a parallelogram. Now I need to find the distance from each of these sides. If I count how far I'm going for BC, I see that's 9. I do the same thing for AD, which is also 9. To find the length of AB, I can use the distance formula, or I can also use something about right triangles. Remember, this is the Pythagorean theorem. So I have 4 and 8. So the distance of AB is going to be the square root of 4 squared plus 8 squared. If that's equal to 9, I'm in good shape. If it's not, then the sides aren't equal. So 4 squared plus 8 squared, I get 8.9. That looks like it's close to 9, but it's not. But since the sides aren't equal, and it's not a rhombus, since the opposite sides are parallel, that's enough to show it's a parallelogram. Let's move on to question 3. we're asked to find out which coordinates might be a parallelogram. The easiest way to do this is just to graph them. So they do A in black, 0, 0, 4, 0, 6, 3, and 2, 3. And actually you'll see that A is a parallelogram right from the start. If I use the other colors, so if I have A, B, 3, 4, and 1, 4, I see that that shape's definitely not a parallelogram. It's actually an isosceles trapezoid. We use green for C. So there's 0, 2, 2, 4. And 4, 2. This shape, I don't believe has any special properties. That's just a quadrilateral. And the last one I have, with blue. And this one here would be a trapezoid. Only one pair of parallel sides, two pairs. So A is the correct answer. For number 4, this one might be a little bit tricky because we don't have actual numbers. But we should be able to find the y coordinate very easy. This is the second time where we're going to talk about boy bucks. Why we do this is because we have a horizontal line, so that means it's going to be y equals. Y is going to be equal to 2c. So we have to make sure our y coordinate is 2c, which automatically takes out a. To find the x coordinate, we need to figure out how far over we're moving. So from 0 to 2b, that's 2b. So I need to move over another 2b, which is going to be 2a plus 2b needs to be my x coordinate. So the correct answer is going to be b. Moving on to the next page, the final one. We have to name the missing coordinates in terms of a given variable. So this one's similar to the last one. Again, we have our y coordinate right away. Y is equal to c. Remember, 20 plus horizontal line, y equals. So right away we know that c is not an option. Where I move over here, I need to figure out how far away I'm moving. So think about what subtraction says. Right here, this length is A, and when we're doing red, that length is B. So that means this black length here has to be A minus B. So that means this length here has to be A minus B. So to find the x coordinate, I have to take negative A and add A minus B. So I'm adding that much, I'm moving to the right that much. And it's going to come out to negative B. So the correct answer is going to be negative B. C. One other way that you could do this is you could say that this looks like it's a line of symmetry, which it is. So it would have to be negative B, C. Let's go on to number 6. We're asked to find the measurement angle BDC, which is this one right here. What we need to know is that this right here, these are parallel lines. Remember, this is a parallelogram. Parallelograms have parallel lines. And right here, these two angles are alternate interior, which means they're going to be congruent. So it's going to be 25 degrees. For number 7, you need to remember the sum of angles in a quadrilateral is 360. If you don't remember that, you can use this n minus 2 times 180 formula. N is the number of sides, 360 now. So I need to add up everything. Whenever I combine like terms, I'm going to get 4x plus 200 is equal to 360. And then it's just simple algebra. X is equal to 40. I always want to make sure that's what I'm supposed to find. What is the value of x? Yes, that's it. And I'm done. The last one is one that really doesn't have a true answer. It says, which of the following quadrilaterals could have diagonals that are congruent? I guess it would be because it says could. Could have diagonals that are congruent, but do not bisect each other. So in rhombus, diagonals are not congruent unless it's a square. But they do bisect. A rectangle, diagonals are congruent and they do bisect. A parallelogram, diagonals not congruent and they do bisect. Remember, if we go to page 1 of this slide of this presentation, you see that a trapezoid, isosceles trapezoid, the diagonals do bisect. So remember what an isosceles trapezoid looks like. We have two sides that are parallel, just the opposite, one pair of opposite sides. And you should see that the diagonals do look like they're congruent, but they don't bisect. So that's going to be the correct answer. So please watch the other videos and good luck on your SOL.